This video will continue our discussion of spherical coordinates by working another example. We want to find the volume of a solid bound by z equals 3. Okay, this is a plane, right? It's parallel with the xy plane at 3. I drew that here on the graph. You can see that red line. This is projected onto the yz plane. We'll make sure you understand where that purple graph comes from. All right, remember to find, to bound rho and to bound phi, I let x equals 0. Well, I get z equals 3. That doesn't change anything. And then this one, I get z equals the square root of y squared. And we learned in the other video, this needs to be the absolute value of y. So, graphing both of those on the projection of yz. So, there's my yz plane. Z equals 3 is that line. And then the purple is our absolute value function. And we want the volume bounded between those two. So, we're looking for this whole, oops, thought it was on my highlighter, this region in here. Do my best to highlight. All right, good enough. All right, so we're dealing with that region inside of there. Here's the deal, though, and this is what's going to make it a bit weird, is if I consider my rho, notice that the length of rho is going to change as I go across there. So I can't use just rho is 0 to 3 because that's not true. That's only true along here. So I got to figure out something else to do. Well, what I can do is just use the formula for z going to spherical. Or, sorry, yeah, spherical. So it's rho cosine phi equals 3. All I did was replace z with its definition from spherical coordinates. But I'm trying to solve for rho because I really like to bound rho. So rho is actually 3 over cosine phi. But that means that rho is, well, 1 over cosine is secant. So 3 secant phi. So this is actually the same thing as rho equals 3 secant phi. So as phi changes, it'll tell me what rho is. All right, let's start writing down our bounds now. Rho is caught between, I have it now, 0 and that function, secant of phi. We're also going to need, not r, we're going to need it phi, and we're going to need theta. Okay, we can grab phi from here. Phi is not totally obvious, but it starts here and goes over. And it's the cone, so it's right down the middle, or the absolute value. So it's 0 to pi over 4, because it's right down the middle. And then phi, we can see if we were to project this, if you let z equal 0, you're not going to get anything but 0, 0. But if I think about looking down onto the xy plane of this graph, right, this is just like a cone with a flat top. It creates a circle, and a circle goes from 0 to 2 pi. So again, if I let z equal 0, it's not going to tell me anything. It's just going to tell me that, hey, 0, 0 makes that 0. Because at z equals 0, it's just a point. But if I go up, I get another circle. If I go up, I get a circle. But if I look down on those circles, I just have the full circle on the xy plane, which tells me it's from 0 to 2 pi. All right, let's set up our volume. So our volume is theta from 0 to 2 pi. Phi from 0 to pi over 4. Rho from 0 to 3 secant phi. Be careful with your angles. I found when I was first working these quite a bit, I was switching phi and theta often, and it would mess me up, and I wouldn't get the answer in the back of the book because I just switched my variables. Just be careful. Right, if I'm finding volume, I let my integrand be a 1. But I also have to put the Jacobian in for spherical coordinates. So that's going to be rho squared sine phi d rho d phi d theta. If you'd like to try to work this one out, this one has a nice pretty answer. So I imagine that the work is probably not as bad either. So I'd give that a shot. The answer to that is 9 pi. So again, this is with rho changing. What I would recommend is take functions that they gave you that are nice and simple and change them with the variable to the definition in that coordinate system. And sometimes that will allow you to come up with a variable formula for one of those rhos or phis or thetas. Theta should always be constants. I think phi would always be constants too, because it's hard for me to imagine an angle like that changing. So I believe phi would always stay a constant, but I don't like to say always for sure. That's the mathematician in me unless I prove it. So there it is. So that's how you change your variable row.